So, what do you like to listen to? Music? Podcasts? Maybe the sound of rain or the crackling of a campfire. But what about listening to the ocean? Not the familiar crash of waves on the shore, but sounds captured deep on the cold ocean floor. Sounds that send chills down your spine. Sounds of something big, dark, and possibly alive. And the most unsettling part is this. The true nature of some of these sounds remains a complete mystery to this day. In 1997, something strange echoed through the Pacific Ocean. Deep beneath the surface, far off the coast of South America, a sound appeared so powerful that it instantly unsettled scientists. It was ultra-low in frequency, massively loud, and unlike anything recorded before. The signal was later given a simple name: the bloop. At first glance, the bloop sounds harmless, almost playful, but what it represented was anything but. It was so intense that it could be detected by sensors nearly 3,000 miles away. Imagine standing in New York and hearing something happening in Los Angeles. Now imagine that noise traveled through deep ocean water, terrifying marine life and oceanographers. Whatever produced it had to be enormous. The signal carried patterns that felt like its source was some living creature. Whales were the first suspects, but even the blue whale, the largest animal in the world, simply couldn't generate a sound that loud. The numbers didn't add up, and that's when speculation took over. If something could produce the bloop, it would have to be larger than anything swimming in today's oceans. People began imagining creatures of impossible size, ancient sea monsters, the kraken. Some even whispered about the megalodon, a prehistoric giant shark thought to have gone extinct millions of years ago, and featured in dozens of videos right here on the bright side. The mystery only grew deeper when scientists mapped the approximate location of the sound's origin. It came from a region close to Point Nemo, the most remote place on Earth. This spot in the Pacific Ocean lies more than 1,000 miles away from the nearest land in every direction. It's so isolated that it's often called the oceanic pole of inaccessibility. Point Nemo is a place few humans will ever see. Because of its remoteness, it has become a kind of graveyard for defunct satellites and space debris. When spacecraft are decommissioned, they are often guided to fall into these waters. It's quiet, empty, almost untouched, and yet something powerful had screamed from nearby. For fans of cosmic horror, this detail felt oddly familiar. In the fictional universe of writer H.P. Lovecraft, the ancient sunken city of R'lyeh lies beneath the ocean near this very region. According to the stories, R'lyeh is where the monstrous entity Cthulhu sleeps. It's a powerful, scary, intelligent creature lying dormant for thousands of years, ready to awaken and bring about the end of the world. Of course, Cthulhu is pure fiction. Lovecraft never claimed otherwise. But once the internet made the connection, the idea took on a life of its own. But science eventually caught up. The bloop recording is still easy to find online. You can listen to it yourself. But it sounds so innocuous that you'll probably be disappointed. And today, we know with certainty that it didn't come from a living creature. Researchers later confirmed that the sound was produced by ice, specifically by an ice quake. Now, ice quakes occur when enormous icebergs fracture, crack, and break away from glaciers. When this happens, they release tremendous amounts of energy, generating ultra-low frequency sounds that can travel across entire ocean basins. These sounds are similar to biological calls, especially when recorded from far away and distorted by water. In fact, scientists compared the bloop to other known icequake recordings and found striking similarities. The source wasn't a monster. It was Antarctica itself during shifting, breaking, and reshaping. For many people, this idea brought mixed emotions. On forums like Reddit, some openly admitted they preferred the idea of a giant unknown life form. Yup. Another strange sound was captured in the early 1980s, deep in the South Pacific, during a scientific expedition near New Zealand. Researchers were exploring the South Fiji Basin, where the ocean floor lies more than 2.5 miles beneath the surface. There were short, sharp, repeating noises echoing through the water. 4 distinct bursts, each one sounding uncannily like a duck's quack. So, researchers called it the bioduck. The sound was rhythmic and consistent. Eventually, the team concluded that the source had to be biological, but identifying exactly what made the sound proved impossible. After sharing the data with colleagues in Australia, did they realize something even stranger? Similar sounds had been recorded in other parts of New Zealand and Australian waters. Decades later, the mystery remains unsolved. Some scientists believe the quacks may not be random at all. They could be a form of communication. Perhaps the sounds may come from Antarctic minke whales, though no direct proof exists. Scientists also noticed that there were several sources of sounds, and when one source spoke, the others fell silent, as if they were listening. It may have been a conversation echoing through the deep, in a language we still don't understand. Imagine a terrifying alarm blaring inside a secret laboratory, announcing that a monster from another planet has broken free. It's an ugly sound, loud, piercing, and oppressive, the kind that makes your skin crawl. In August of 1991, scientists recorded something eerily similar. Not in a lab, but deep beneath the Pacific Ocean. Across vast areas of the ocean, a strange, repeating signal began to appear at different times. It consisted of narrow, rising tones that lasted several seconds each. Researchers named this sound upsweep. It's detected most often during the spring and fall, leading scientists to believe it may be connected to seasonal environmental changes or changes in the source itself. But what exactly was producing it? No one knows for sure. The only thing scientists can say with confidence is that upsweep appeared near areas of suspected volcanic activity. But if this sound is natural, why does it seem so precise, so consistent? It almost feels artificial, as if a secret underwater facility is periodically broadcasting a distress signal from the depths of the ocean. Since its discovery in 1991, the upsweep signal has gradually weakened, making it one of the strangest and most unexplained phenomena ever recorded beneath the ocean. Now, there's another mysterious sound known simply as slow down. True to its name, this signal steadily decreases in frequency over 7 minutes before fading into complete silence. It was recorded in May 1997 on a hydrophone array located in the eastern equatorial Pacific Ocean. At first, slow down doesn't seem especially loud. But here's the chilling part. It was picked up by 3 separate sensors placed nearly 3,100 miles apart. Imagine how deafening and terrifying it was near the source itself. So, what caused it? The most widely accepted theory suggests that a massive drifting iceberg slowly came to a stop and ran aground. The idea is surprisingly plausible. A colossal block of ice is scraping along the seafloor, grinding forward until it finally halts. The location supports this theory as well, since the sound originated near shallow waters and small islands. Because of this, many scientists classify slow down alongside the bloop as a cryogenic noise caused by ice. Still, it remains just a theory. Officially, the sound has never been identified. And there's yet another eerie recording from the ocean. This one sounds like a moan, but scientists named it whistle. Go figure. It was recorded in 1997 and gives the unsettling impression that something enormous is sitting on the ocean floor and whistling. Researchers believe that something could be an underwater volcano. When they compared the whistle signal to previously recorded volcanic sounds from the Eastern Pacific, they found them very similar to each other. Most likely, All these sounds are of a natural source, volcanic eruption or iceberg collision. But it's still pretty scary to hear something like this while driving. It would be especially unpleasant to be directly above an erupting underwater volcano. Well, yeah.
A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events, like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever ANITA has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They publish the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Wiesel and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, Researchers have been designing setups in both Antarctica and South America to catch these rare particles. Anita is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from Anita's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what Anita had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Whistle explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas, like maybe it's some new kind of physics, or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since IceCube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.
Do you know that our planet has scars? One of them is located in North America. This scar can tell us many cool things about the history of Earth, but the most interesting thing is that it could change the appearance of our continents and break our world. But for some reason, this scar hasn't done it yet. And that's not even the most interesting part. The coolest thing about this scar is that it might hold a giant source of clean, cheap energy. So let's go to Kansas to find out what it is. So, 1.1 billion years ago, a giant rift formed in the crust of our planet on the territory of the modern U.S. Midwest. It's called Broken Heart. This giant crevice is filled with solidified magma, and from afar, it looks like a real scar. But how did it show up? Broken Heart was an ancient rift valley, a huge geological fault forming elongated hollows in the Earth's crust. It occurred because tectonic plates had moved apart. It's like the details of a jigsaw puzzle that suddenly started to separate. At that moment, thousands and even millions of tons of magma spilled out from the depths of our planet. That event looked like a real apocalypse, lasting about 100,000 years. But then it stopped, and scientists don't know why. If the rifting process had lasted longer, then most likely the continent of North America would look different today, or it wouldn't even exist at all. Right now, this fault looks like a giant horseshoe that stretches from Kansas north to Lake Superior and south to Michigan. But some studies indicate that the fault may be larger and extend even further south, and the width of the fault might equal the width of the Red Sea. After the rifting stopped, the entire valley got covered with hills and trees. The fault itself is covered with a thick layer of sedimentary rocks, so it's quite difficult to track. The most noticeable parts of the rift are in the Lake Superior area. Now everything looks calm and beautiful, but in the past, there were fountains and rivers of lava, earthquakes, a boiling pot on a planetary scale. All that remains of it are deposits of basalt, a dark, dense rock that forms from cooled lava. There was so much basalt that its weight pushed the valley deeper and deeper into the Earth's crust. Even when the eruptions and rifting stopped, the valley continued to sink because of the huge mass of the sediment. Then, massive sections of the Earth's crust on both sides of the valley began to contract, and the pieces of the puzzle slowly started to come together. This led to a large-scale ejection of volcanic material upward, and along with basalt, deposits of copper rock appeared in the valley. People mined this copper for about 8,000 years until the end of the 20th century. The copper mines were eventually shut down, but now it seems the industry is making a comeback. However, Broken Heart is not interesting to people just because of its copper reserves. It holds something more valuable and useful for our civilization. Scientists believe that this valley hides massive reserves of hydrogen, and this substance can help us switch to a cleaner, cheaper, and more efficient energy source. If hydrogen fuel becomes widely available, everyone will switch to it, leaving behind the costly, noisy, and polluting process of oil production. Now, I'll bet hydrogen is a remarkably familiar word to you. It doesn't sound like the discovery of the century, and people have been using it for a long time. On one hand, you're right, but not quite. 90% of the hydrogen produced by humans is used as a raw material for the chemical industry. Hydrogen is used to produce ammonia for fertilizers, methanol for fuel and solvents, and to purify crude oil. Manufacturers of glass, cement, steel, and other metals are considering using hydrogen at their factories for more efficient production. Hydrogen can become an alternative to fossil fuels, that is, oil and gasoline produced from them. Cars, ships, trains, airplanes, and power plants, all of these may switch to hydrogen soon. In this case, production can become cheaper and better for nature, but this will work only if we find open sources of hydrogen. You see, about 95% of the hydrogen we use is produced from fossil fuels. We gasify coal, oxidize hydrocarbons, and extract hydrogen from methane. All of these production methods require energy. But the worst part is that they lead to large emissions of carbon dioxide into the atmosphere. But what if we find sources of pure hydrogen that don't require processing? Then we'll save energy for its production and make the planet cleaner. But where can we find such sources? Scientists say that there are many of them all over the planet, and one of the largest is located in the Rift Valley in the U.S. Midwest. But what's the problem with going and mining it? Well, it's not that simple. To extract pure hydrogen, you need 3 conditions. The first is the source of hydrogen itself, which is quite logical. The second is reservoir rocks, that is, natural containers where this hydrogen is stored. And the third is natural seals, which prevent the gas from escaping. In other words, these seals work like a cap on a bottle. They don't allow the substance to escape. So in general, it's necessary to find where hydrogen is released, where it accumulates, and where it's stored. When these conditions are met, natural resource extraction companies can start working. But how does hydrogen appear altogether? Well, let's go over the basics of chemistry. Hydrogen and oxygen compounds form water. This means you need to split the water into hydrogen and oxygen. This process often occurs in nature. There are many places all over the planet where this happens. Scientists are confident that at least 30 U.S. states have hydrogen reservoirs. And if people detect them, we will accelerate the energy transition to safer and more efficient fuels. Thousands of cars drive around using gasoline. Many of you know the smell of exhaust fumes, that thick polluted air that's hard to breathe. What about electric cars? They must be improving the situation, right? Well, here's another problem. Producing batteries for these vehicles harms nature. The materials used to make batteries are lithium, cobalt, and nickel. Their extraction involves a large release of toxic materials, not only into the air but also into the water. Transporting these batteries also creates a large carbon footprint. Producing a single electric car emits about 4 tons of carbon dioxide. To make up for that, the owner needs to drive it for at least 8 years. That's how long it takes to offset the emissions a regular car would produce. What about reliability and convenience? What will you do if the battery runs out during the trip and there are no charging stations nearby? This problem will be solved in the future with the growing popularity of electric cars. Now, scientists believe that over the past billion years, the Earth's crust has split enough water into hydrogen and oxygen. Our planet keeps this gas in the ground, waiting for us to start using it. According to calculations, even considering all the technologies and production capacities of our civilization, the reserves of hydrogen in the bowels of the planet are enough to supply us with energy for 170,000 years. That's why the giant rift in Kansas attracts scientists from all over the world. Huge quantities of basalt and other rocks can react with water to release hydrogen. And now scientists are looking for places where this material accumulates and is stored.
A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of 2 school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue: the two sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue: the gap wasn't one continuous line. There was some kind of soil bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole "Africa is splitting" talk back. And here's the thing: even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between two tectonic plates, the Somali Plate in the east and the Nubian Plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali Plate could split completely from the Nubian Plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this sixth ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali Plate and the Nubian Plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift system. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift system. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift System's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever.
India could split horizontally into two parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Calcutta and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely a tenth of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept, the delamination of the Indian plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between two buns. Take one of those layers out of the sandwich, and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia-Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia-Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where 2 or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the sea floor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya, first in 2018 and then again in 2023. The local population named the biggest of them the Grand Canyon. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into 2 subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The 2 are gradually moving away from one another, which causes the formation of crevices within the rift valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into 2 continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the land masses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today. At the end of December 2021, an underwater volcano with a rather exotic name, Hunga Tonga, woke up after several years of sleeping. It did that with so much energy and strength that people heard the eruption from over 100 miles away. Then it went back to sleep. But a couple of weeks later, it woke up again with a force 7 times greater than the first time. It broke the island above it in 2 parts. The lightning storm that started because of the eruption was the most intense in recorded history. The sound waves from the eruption traveled around the planet several times. Someone even heard a loud boom from it in Alaska. And it started the first known mega tsunami since ancient times. This tsunami took the lives of 2 people as far as Peru and caused trouble for 2 fishermen in California. But that's not all. This eruption could change the weather patterns on Earth for years. You may see the first proof in the summer of 2024, which is forecast to become much wetter than usual. Scientists believe the eruption was caused by gas building up to a critical point. Different minerals, including anhydrite quartz and sulfides, were building up for several months until they blocked the flow paths and sealed the gas within Hunga Tonga. Normally, when a volcano erupts, the fumes cause a temporary cooling effect on Earth's surface. But Hunga Tonga's eruption was different. It didn't produce much fumes, but released a massive amount of water vapor, roughly equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned huge amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its effects on our weather patterns. They can't tell exactly how long these effects might last either. This is because the only way to measure stratospheric water vapor is with satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. Experts from different countries started analyzing satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and, most importantly, what this would mean for the planet. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. In the following years, there wouldn't be enough water vapor left to enlarge this hole. It looks like Hunga Tonga will have just a minimal effect on global average temperatures. But there are some surprising, lasting regional impacts. One of the scientific models forecasts colder and wetter winters for northern Australia until about 2029. In North America, it predicts warmer winters, and Scandinavia could have even colder winters. This is just one study though, and one approach to understanding how the eruption of Hunga Tonga can change our weather. We do have at least one example from history when a volcano eruption changed the world. Over 2 centuries ago, in 1815, Mount Tambora erupted and caused the year without a summer. In the following year, the winter was unusually cold and wet weather across Europe and North America. A recent study confirms that 1816 wouldn't have been this cold without the volcanic eruption. The immediate effects of the eruption were catastrophic, with tsunamis destroying homes, claiming 10,000 lives, and 80,000 more who fell ill in the aftermath. The eruption of Mount Tambora was one of the strongest in the last 1,000 years. It had ejected an enormous amount of sulfur dioxide into the stratosphere, which quickly spread across the world. It resulted in the coldest year in at least the last 250 years. In May, frost wiped out most of the crops in New York, Massachusetts, New Hampshire, and Vermont. By June, heavy snow covered the ground in Albany, New York, and Dennisville, Maine, and New Jersey had 5 straight nights of frost. The cold continued into late summer, which should have been the harvest season. In July, lakes and rivers were still frozen as far south as northwestern Pennsylvania, and frost stayed in Virginia until late August. Temperatures would drop from above normal summer highs to near freezing within just a few hours. The weather was completely unpredictable. Prices of food skyrocketed. The cost of oats for horses, which were the main mode of transportation, also rose sharply. Some people believe this situation inspired Carl Drees to invent the bicycle in 1817 as an alternative transportation method. Tambora changed weather patterns completely for not just 1, but 3 years. The whole planet got colder, and as crops failed, probably at least 1 million people starved. Scientists don't have solid evidence of volcano eruptions that have taken more lives than Tambora. But the Krakatoa eruption in Indonesia in 1883 is far more famous than Tambora because information about it spread worldwide via telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Still, it was less powerful than Tambora's eruption. The island that once hosted Krakatoa disappeared in the eruption, but new eruptions began less than 50 years later and created the Child of Krakatau cone in the center of the caldera of the old eruption. The new volcano still comes to life from time to time. Mount Vesuvius's eruption, which took down Pompeii, is one of the most well-known volcanic disasters in history. It took around 2,000 lives, much fewer than Tambora. According to a famous Roman author of that time, the eruption lasted 18 hours. Pompeii was covered by a layer of ash and pumice that was thicker than twice an average human height. The nearby coastline also changed dramatically. In today's world, the after effects of volcanic eruptions are often more dangerous than the eruption themselves. Thanks to advances in technology, we can now predict volcanic eruptions more accurately and use safety measures like evacuations and flight cancellations. But there's still a lot of risk that changes in weather patterns and drought all over the world, especially in areas like India, East Asia, and East Africa that are affected by monsoons. Volcano eruptions can also have effects you wouldn't probably expect, like the evolution of dinosaurs. These guys were once the size of cats, waiting for their time to shine. It came around 230 million years ago. This time is known as the Carnian pluvial episode. Before it, Pangaea was a dry and arid supercontinent. But then, there were 4 major volcanic events that pumped huge amounts of carbon dioxide into the atmosphere. Global temperatures and humidity spiked because of it. These massive eruptions most likely happened because of the Wrangellia Large Igneous Province eruption in what is now British Columbia and Alaska. This prolonged volcanic activity created the right conditions for dinosaurs to blossom and diversify, and also for the rise of other groups, like modern conifers, ferns, crocodiles, turtles, insects, and early mammals. With higher temperatures and more rainfall, terrestrial plants have evolved, and humidity-loving ones have become dominant. Without those changes in the world, we could have a completely different natural history. There's some solid proof that volcanic activity has really changed the weather patterns back then. Scientists have found layers in the Earth's core that show different types of carbon. It means there were 4 massive releases of carbon dioxide into the atmosphere. The data on mercury and carbon together shows that the spike in mercury levels was thanks to a major volcanic event that affected the global carbon cycle, and not just local eruptions. In 2020, strange signals from deep beneath Antarctica sent shockwaves through the news. Within days, headlines exploded. NASA had found a parallel universe where time runs in reverse. But what really happened? And what did scientists actually detect? Well, this story is a case of madness, misunderstood experiments, and the human need to believe in mystery. Even today, every few months, someone reposts a headline screaming that NASA found a parallel universe in Antarctica. A universe where time flows backwards, and people believe it. But no, NASA didn't find a mirror world under the South Pole, or some sort of a backwards reality where people age in reverse or speak in rewound sentences. They did find something curious, though. Here's what actually went down. Scientists were flying a strange-looking instrument over Antarctica called ANITA, short for Antarctic Impulsive Transient Antenna. ANITA is a machine that floats over Antarctica, basically a giant balloon with antennas. It listens for tiny space particles called neutrinos. Neutrinos are super small and ghost-like. They have almost no weight and go through stuff like it's not even there, even entire planets. Usually, these neutrinos come from space and rain on Earth from above. Most neutrinos, the common low-energy ones, just fly right through the Earth like it's air. They're like tiny bugs flying through a chain-link fence. There are some very high-energy neutrinos, though. They're super rare and they interact a bit more often with matter, and they can get blocked. If high-energy neutrinos hit something dense enough, like the rock and metal inside Earth, they might finally bump into a particle and get absorbed. That's more like fast tennis balls that hit the fence once in a while. Low-energy neutrinos, which are everywhere and pretty harmless, are pretty undetectable. But these high-energy guys are exactly what ANITA can detect. When they slam into ice, they send some radio waves that are easy to listen to. This faint radio signal is called the Askaryan effect. And yep, that's exactly why ANITA is flying over Antarctica. That's because the ice is pure, dry, and quiet. It's perfect for catching those rare signals. So, what did ANITA detect? It detected something rising up from below the ice, like a high-energy neutrino coming from the Earth. What? Okay, let's think logically. Maybe it started somewhere in the north, traveled all the way through the Earth, and popped out the other side. Still, that's super weird. That's not supposed to happen. Neutrinos with that much energy should have been stopped inside the planet. Like we said, get absorbed. So, scientists caught a little bit of a brain bug. That shouldn't be possible with our current physics, unless something we don't understand is going on. And when you're faced with something bizarre, you explore all options, even the wildest ones. The nightmare began. A group of researchers published a paper suggesting that this strange signal might make sense in a CPT symmetric universe. CPT stands for charge, parity, and time. These are basically three ways to flip the universe. Charge means swap all particles to their opposites. For example, swap electrons, the guys with the negative charge, with positrons, their antimatter twins with the positive charge. Parity means mirror the universe, literally like looking at it through the mirror. Left becomes right and right becomes left. And time, of course, means run time backward, like rewinding a video. Now, there's a big rule in physics called CPT symmetry. It says that if you change all three of those things at once, the laws of physics should still work the same. This is kind of insane, but if you took the entire universe and swapped matter with antimatter, mirrored it, and reversed time, it would still follow the same physics. Why is that? Well, in our universe, an electron bumps into a positron, and they annihilate into photons. Cool. Now take that, mirror everything, and what do you get? Well, photons spontaneously turn into a positron and an electron, but mirrored and reversed. It's still the same physics, even if it's backwards. The equations still check out, so nature thinks this is valid. So here came the crazy part. Some physicists thought, what if the Big Bang created two universes? One is ours, made of normal matter going forward in time. The other is a mirror twin, made of antimatter, going backward in time from our perspective. This doesn't mean that someone in the other universe feels time going backward. To them, time flows forward, just like it does for us. But from our point of view, they're moving from our future toward our past. And vice versa. To them, we're weirdos who move backwards. And if both universes are exact CPT mirror images of each other, that would mean same physics, same rules, just symmetrical. Same rules, just symmetrical. This isn't some crazy sci-fi theory, even if it sounds like it. It helps explain weird physics mysteries. For example, why there's so much matter in our universe but not much antimatter, even though they were supposed to be created in equal proportions. Or why the universe is so symmetrical and balanced in some strange ways. So, coming back to the neutrinos, some scientists suggested that maybe those upward flying particles could be coming from that CPT mirror universe, poking through into ours, like a crack between two symmetrical realities. And if you look at it like that, this is quite a wild take. It's speculative, it's not proven. It's more of a cool thought, but the media immediately blew up. They ran a piece with the headline that said we found proof of a parallel universe going backwards in time in Antarctica. And all the other big tabloids picked it up. They made it sound like NASA had actually found a parallel universe. Time travel is real. Multiverse is confirmed. Meanwhile, people who worked directly on Anita immediately caught brain damage. They tried to jump in to say that's not what happened at all. They explained that the signals were unusual, yes, but there were plenty of normal explanations that didn't require rewriting the laws of physics. It could even be just an experimental error. Maybe an unusual particle behavior or gaps in how we model neutrino interactions. Of course, no one listens to experts about what experts discovered. And once an idea like that hits social media, it becomes nearly impossible to put back in the box. But that also doesn't mean that the multiverse definitely isn't real. Far from it. Physicists are still exploring the concept and assume that some of those potential universes, if they exist, could have different laws of physics. One idea, called the many worlds theory, comes from quantum physics. It says that every time something can happen in more than one way, like a particle moving or a decision being made, all those possibilities actually happen, but in separate universes. So there could be endless versions of reality, each slightly different, branching off from every event. Maybe in one universe, dinosaurs never went extinct. Maybe in another, you never sent that embarrassing text. Another theory is called the bubble universe theory. After the Big Bang, the universe expanded incredibly fast in a process called inflation. Some scientists think that inflation never fully stopped and is still happening in some regions. That would mean new bubble universes are constantly forming, each with its own version of physics. Our universe would just be one bubble in a giant cosmic sea of others. The third idea is about shadow matter. Dark matter is invisible, but its gravity affects the universe. Some scientists think it could be made of particles similar to the ones that make up regular matter, but they're just hidden from us. This mirror, or shadow matter, could form entire invisible galaxies and even life, all existing right alongside us. Maybe we just can't detect it in any way, except through gravity, for now. But in physics, all of those are just theories, mathematical possibilities. We have no direct evidence that it's real. If we ever find one, though, let's now hope it won't be the boy who cried wolves scenario.
Ooh, you're diving into the dark and icy waters of Antarctica. The eerie blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well, off the western coast of Australia and near New Zealand. They recorded similar but higher pitch signals, which they named bio-goose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on bioduck and biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The biogoose sounds from the waters off Australia and New Zealand likely belong to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a "hey" of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike bioduck, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping, reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales, specifically Bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of Bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound source was a giant sea monster, kraken, or some other creature. The hype around the bloop didn't last very long. Scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. How about we end this video with a mystery that still baffles scientists? Meet upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it.
The South Pole is more than penguins and endless snow. There's a hidden ghost world within it. Look, it's right here on the globe. Don't confuse Antarctica with the Arctic, which is at the top of our maps. Much smaller in size, and, let's face it, way less mysterious. The ice sheet covering Antarctica is about 1 to 3 miles thick, which is up to 16 Eiffel Towers stacked on each other. This massive blanket hides the true features and contours of Antarctica's land. We still don't know much about this mysterious continent, and it is ice and snow that are to blame. We still don't even know the true shape and size of this continent. Mapping Antarctica without some huge shovels is an incredibly hard task. But satellites learned to penetrate the ice with their cameras. And now we know there's actually an enormous, dramatic ancient landscape beneath the snow. The ghost of the past. About 90 million years ago, Antarctica was a much warmer place. It was actually a lush rainforest with tons of plants and probably teeming with life. It even had rivers flowing through it. Then the ice came. This happened about 34 million years ago, during the transition from the Eocene to the Oligocene, when our planet cooled significantly. It was the beginning of one of our several ice ages. The land remained, but now was hidden under ice and snow that got thicker and thicker. To a regular eye, Antarctica turned into a white desert, vast, flat, and featureless. Time went on. This massive ice sheet moved around, smoothing and shifting the ground beneath it. Over the millions of years, it changed what the land looked like. Now, if we looked under the ice, it wouldn't hold any signs of the original South Pole, except for one place. In areas where the ice is especially thick and doesn't move much, like in East Antarctica, it has actually worked the other way around. It became like a super thick blanket that protects the land. Normally, things like wind or rain slowly wear away the ground over time, changing its shape. But since we have this protective ice blanket, it prevents these natural processes from reaching the stuff underneath. So, the ground stayed almost the same for millions of years, like it's been frozen in time. This special area near the Aurora and Schmidt subglacial basins has become the ghost of Antarctica's landscape. This place was barely touched even since it was first covered in snow 34 million years ago. This is a historical footprint, a place that can tell us what Antarctica's ground looked like before it became a freezing nightmare. As scientists peered under East Antarctica, they saw an amazing ghost. The traces of the rivers that were flowing there millions of years ago, various valleys, and some weird little islands, as well as 3 big chunks of land shaped like the letter U. Hey, what's that all about? You see, the continents on our planet are moving constantly, sliding along the red-hot lava mantle like cereal on milk. Over history, they came together and broke apart several times. Hundreds of millions of years ago, several continents were a part of one enormous Gondwana. Antarctica was one of them. It used to be one huge landmass. But when Gondwana broke apart, the poor continent got stretched by tectonic forces. Parts of land were pulled away from each other. Whoosh! And they got torn apart. And that's how we got these big chunks or blocks of land under thick layers of ice. In any case, scientists now want to explore this ghost a bit more. But to study it deeply, they need to actually drill down through the ice, like using a straw to get to the bottom of a thick shake. This will help them pick up some rocks and dirt from way below to learn more about the Earth's history and climate. Antarctica is the 5th largest continent in the world, approximately bigger than the entirety of Europe or Australia, competing with the entire South America in size. Aside from East Antarctica, we discussed there are several more regions: Antarctica Peninsula, South Pole, West Antarctica, and the Ross Sea. The continent is basically a frozen sandbox, and all its hidden, mysterious landscape is actually less explored than Mars's terrain. We only know for sure that without ice, it wouldn't just be flat and empty, but an entire world full of big mountains, huge canyons, and even fiery volcanoes. Some of these volcanoes are so huge that they peak above the layers of snow. In West Antarctica alone, there are at least 138 volcanoes, though only about 8 or 9 are active today. One of the craziest ones is Mount Erebus, the southernmost volcano and the tallest one on the continent, about 12,500 feet high. And deep beneath the ice sheet, this guy hosts incredible, beautiful subvolcanic caves. The temperatures there are warm enough for t-shirts. The Antarctic Peninsula, or Lesser Antarctica, looks like a bunch of mountainous islands deeply underground. It has newer volcanic rocks that are part of the Pacific Ring of Fire, which is like a giant circle of volcanoes and earthquake zones around the Pacific Ocean. The Greater Antarctica is a huge part, almost as big as Australia. It consists of East Antarctica and the South Pole. Beneath the ice, it's a place of rocks that have been around for a very, very long time, including the special zone we mentioned. You probably know that Antarctica is nearly devoid of humans. No wonder, with a mean temperature of about minus 46 degrees Fahrenheit. But even though this place is horrifyingly cold and deserted, life still clings on. You guessed it, in the underworld. In 2017, scientists found DNA traces of algae, moss, and even possibly unknown small animals in the deep caves. That means that even in such crazy conditions, there are still unique ecosystems thriving in little isolated warm pockets beneath the snow. There was another incredible find beneath Antarctica's Ross Ice Shelf, a lively ecosystem vibing within an underground river. Scientists have long suspected that Antarctica's underworld should have some freshwater lakes and rivers. One day, a satellite spotted a groove there. They decided to explore it and used a hot water drill to melt their way through the ice. As they reached the underworld, they dropped a camera into one of those hidden fresh rivers. And at first, they thought they'd find just some rocks or something. But instead, they stumbled upon hundreds of amphipods, tiny shrimp-like creatures. Little ones instantly swarmed around the lens. Shrimps blocked the camera and scientists couldn't check out what they wanted to. Pretty funny, but at least that means that there really is an important ecosystem deep within Antarctica. Now, they're gonna explore it. And all this is just the beginning of the mysterious underworld. Antarctica's snow also hides the deepest canyon on Earth under the Denman Glacier. Well, Mariana Trench is still the deepest point on Earth, but it's a part of the oceanic crust, geologically speaking. Also, in 1958, explorers found a huge mountain range under the ice, as big and tall as the famous Alps Mountains. The range stretched for about 745 miles with peaks as high as 1.7 miles. And all this magnificence is buried under tons of ice. Who knows what else we might find there? Antarctica holds about 60% of our entire planet's freshwater, which means it would be pretty bad if it melted. For example, there's this Doomsday Glacier, officially known as Thwaites Glacier. It's a huge ice formation, about the size of Florida, and it's melting right now. Every year, the sea levels rise by 4% because of it. If this guy melts away completely, the sea levels all around the world will increase by 2 feet, which might not sound like a lot, but it would be catastrophic for coastal areas. Luckily, researchers have found that even if its ice shelf were to collapse in the next 50 years, the glacier itself wouldn't retreat as quickly as they feared. It's still losing ice rapidly, but it would be quite a slow process. Look at those lush coniferous forests and tundra. What a wonderland! You may have mistakenly thought it's Canada, but it's not. It's Antarctica, about 34 million years ago. So what makes Antarctica this frigid today? It turns out a mix of dropping carbon dioxide levels and some tectonic shuffle played a huge role in transforming this ice-free paradise into the frozen continent we know now. About 50 million years ago, CO2 concentrations were sky high, strutting around at around 1,000 to 2,000 parts per million. But as those levels tumbled down, global temps started to drop, paving the way for the mighty ice sheets that later took over Antarctica. While the CO2 dive was happening, tectonic activity was also working its magic. The big split between South America and Antarctica opened up the Drake Passage, which created the Antarctic Circumpolar Current. This powerful current acted like a bouncer, keeping warm air and ocean currents from crashing the Antarctic party, and helping keep things rather frosty. If you mix up Australia and Antarctica, you're not that wrong. These two continents used to be one. If you mix up Austria and Australia, it's much worse. By the way, don't fall for the internet myths and memes. There's no help desk in Austria specifically for people who intended to fly to Australia. Now, look at this magnificent Australian pink beach. It's precious, and not in a figurative sense. Those mysterious pinkish sands are actually garnet, and it's widely used in jewelry. Geologists studied those sands and came to the conclusion that the garnet contained there is older than local mountains. That doesn't make sense, right? In fact, it does. You see, Australia didn't used to be this very detached continent as it is now. Many millions of years ago, Australia and Antarctica were part of the supercontinent Gondwana, and glacial erosion released the garnet, which eventually made its way to the beach. These sands formed when South Australia was flat and chill, long before the mountains appeared. Most garnet gets washed away, but this batch has a rich history, tracing back to glacial rocks in the Transantarctic Mountains. So this pink sand comes from an ancient mountain range hidden under Antarctic ice. Not only does Antarctica ice hide gems like garnet, if you look harder, you might find entire buildings. Sounds insane, but this is exactly what a British explorer did. His name is Chris Brown, and he uncovered an entire building beneath the ice. He was traveling to the pole of inaccessibility, and it all started with a bummer. Chris and his son had their plane broken. Suddenly, they spotted a lone bust peeking out of the snow. This place was an old meteorological station. Despite freezing conditions, Chris and his son Micah had a blast exploring. Chris is on a mission to conquer all 7 earthbound poles of inaccessibility and has tackled 5 so far. I guess you already know that Antarctica is the largest desert on Earth, much larger than the Sahara or the Gobi. Still, despite being the driest continent on Earth, it boasts a seriously weird waterfall. Nestled in the mesmerizing McMurdo Dry Valleys, it's 5 stories tall and looks like it's gushing blood. It's even called Blood Falls. It may look outlandish and even frightening, but its nature can be easily explained. The water that creates this crimson cascade was once a salty lake, but over time, it became sealed off from the outside world when glaciers formed on top of it. Now, this ancient water hanging out 1,300 feet below the surface has cranked up its salt levels to 3 times saltier than the ocean. This salt water is also loaded with iron and gets 0 oxygen or sunlight. When the iron-rich water trickles through a crack in the glacier and meets the air, it rusts up, turning dark red. You may have mistakenly heard that no bug species belongs to Antarctica, but it's not exactly true, because there's this tiny Antarctic midge living there. Plus, there are some spiders too. Those aren't your average spiders hanging out in the darkest corners of your apartment. Those are critters lurking in the chilly darkness of the Antarctic ocean floor. These little marine creepers are actually arthropods and can stretch around 20 inches across. As if that wasn't bizarre enough, they also breathe through little holes in their legs. Quick question. What's the color that you associate most with Antarctica? I'm sure it's white. That's my association too. However, Antarctica may look like a slice of watermelon. That colorful snow comes courtesy of a tough little algae called Chlamydomonas nivalis. When things start to warm up during the Antarctic summer, these little guys release their vibrant red and green spores, painting the snow in wild and funky colors. But it's best to steer clear because that snow is not just a pretty sight. It's also toxic and definitely not edible. Searching for fossils is always a blast, but when you're in one of the most remote spots on the planet, it gets even more exciting. A diverse team of scientists recently hit the mother lode, pulling in over a ton of fossils from ancient marine life, dinosaurs, and birds from the late Cretaceous period, about 71 million years ago. Their adventure kicked off with a flight to South America, followed by a 5-day trek through the infamous Drake Passage. Upon reaching Antarctica, they set up camp using helicopters and inflatable boats. You might be thinking, why dig in Antarctica with all that ice? Well, it turns out there are places where rocks pop up, depending on the season. The team went to James Ross Island, located in the Antarctic Peninsula, and they went there during February and March. And that's one of the few parts of Antarctica where in summer, rocks are exposed, and those rocks can come from the age of dinosaurs. The expedition was a success, as they discovered over a ton of remarkable finds. Next up, the fossils will head to Chile before making their way to Pittsburgh's Carnegie Museum of Natural History. Among their discoveries, they found relics dating back about 71 million years, alongside some around 67 million years old, including plenty of snails, clams, and various marine creatures. Yikes! Look at this creepy sea worm. It could live in LA and be a star in a horror movie, but it chooses to call the chilly waters of the Southern Ocean near Antarctica its home. These worms can grow up to 8 inches long and 4 inches wide, but don't let their spooky exterior trick you. Research suggests they might actually be superheroes in disguise, playing a vital role in keeping ecosystems buzzing. Now, see that head? It's not really a head, it's just a retractable throat that helps this toothy creature chow down on its meals. Antarctica has many creepy critters to offer. Let me introduce you to the Antarctic strawberry feather star. It's not like Patrick from SpongeBob though. It's more like a deep-sea creature straight out of a horror movie. Picture this, 20 wiggly arms, some stretching up to 8 inches, all decked out with these bizarre little bumps. Yikes indeed. Back in 2014, scientists buried 34 seismic monitors in the snow on the Ross Ice Shelf, which is huge. Think of it as an ice slab the size of Texas, just chilling over the Southern Ocean. These clever little machines picked up a nearly non-stop buzzing. Even though our human ears usually can't catch these low-frequency sounds, scientists have worked their magic and made them audible for us. They even shared the creepy audio online. A glaciologist from the University of Chicago says that if you could hear this vibration, it'd sound like a swarm of cicadas taking over the backyard in late summer. But these glacier explorers weren't trying to capture spooky tunes. They're actually on a mission to monitor the Ross Ice Shelf because things are heating up, literally, and the ice is melting faster than ice cream on a hot day. Ice shelves are like Earth's safety plugs, keeping all that massive ice from surging into the ocean. So what exactly is making all that noise? It's likely just strong winds whipping across ice dunes, creating a kind of natural vibration.